Good evening everyone. As we had promised, in the next class we will take up some very good problem on the concept of relative velocity. So now we start the class with a problem. Look at the board. Problems. Say problem number 1. There are two aeroplanes are flying in the vertical plane. Look at the board. So board is supposed to be a vertical plane. Say plane A is moving with constant velocity, say 100 root 3 meter per second, making an angle of 30 degrees from the horizontal. In anticlockwise sense. Look at here. So this is the horizontal, this is the vertical plane. Say plane A headed in this direction, say with the speed VA 100 root 3 meter per second at 30 degree. At the same time, another plane B, in fact aeroplane B, headed at 60 degree, say with the speed VB. However, these two speeds of the two aeroplane A and B are measured with respect to the ground frame, supposed to be stationary, VA and VB at 60 degree. Now say one of the passenger of the aeroplane A sees that at t is equal to 0, perpendicular distance is 500 meter, and also one of the passenger of A sees that plane B or aeroplane B is moving perpendicular to the line of motion of A. After some time, say t is equal to t0, aeroplane A escapes being hit by the aeroplane B. Then we have to find this time t is equal to t0 in second. However, this problem belongs to IIT JEE Advance 2014 of my country India. It is very prestigious examination of my country India. So look at how we are going to find this time t is equal to 0. However, just we have to use the concept of relative velocity. Look at how. So here this is 30 degree. So make a 30 degree from here or there, because it is 60 degree, this way or that way. Why? Why we are doing like that? Because of the fact that one of the passenger of the aeroplane A sees that the aeroplane B is moving perpendicular to the line of motion of A. So here line of motion of A. What does it mean? It means that in this direction, look at here, in this direction, so the component of velocity of aeroplane B in this direction is VB cos 30. So this is VA. The VA must be equal to VB cos 30, otherwise the statement of the problem contradicts. So here we equate VA is equal to VB cos 30. So this implies VB is equal to VA over cos 30 degree, cos 30 degree. Put the value of VA here, 100 root 3 meter per second, 100 root 3 meter per second over cos 30 root 3 over 2. So root 3 has cancelled out because it is not equal to 0 and already defined as well. So this comes out to be VB here comes out to be 200 meter per second. So now the velocity of aeroplane B with respect to the aeroplane A, because one of the passenger of the aeroplane A sees, that is why we are talking like that. So in this direction, so what is the velocity of the aeroplane B perpendicular to the line of motion of aeroplane A? So here it is VB sin 30, VB sin 30. So the aeroplane A has no velocity in this perpendicular direction. So the velocity, in fact the relative velocity of the aeroplane B with respect to the aeroplane A in this perpendicular direction is, look at here, because there is no velocity, 0, it means this velocity however magnitude of velocity, this comes out to be VB sin 30. So VB comes out to be 200 meter per second and sin 30 is half, so that much meter per second. This comes out to be 100 meter per second. Now with respect to A, in that particular direction A has got no velocity, only B has got velocity, VB sin 30 degree. So the relative separation in this perpendicular direction is 500 meter. So we are in a position to use dVt. In short, distance is equal to speed into time when speed is constant. So otherwise we have to use x motion or y motion. So if things like that, so we may take the help of dVt. So this is the direction, and now we are going to use here distance is equal to speed into time. So here the t is the time, so t is equal to t0. In fact t0 is the time, because here t is equal to t0, A escapes being hit by the plane or the aeroplane B. So that is why T0 comes out to be d over this V. So this V is already calculated here. So this is say V 100 meter per second. So here say V, d is 500 meter is divided by 100 meter per second. So meter is cancelled out here. This comes out to be 5 seconds. That's the problem. Our very nice problem. We take the help of the relative velocity, and because velocity is perpendicular, so these two in this direction, so velocity of B or velocity of A with respect to each other comes out to be 0. Of course, that is why these two are equal here. These two are equal. Now just we are going to take the problem number 2 here. Very famous Rain Man problem. Rain Man problem. Very pronounced Rain Man problem. We have to take a problem. Problem is that a man is outside and there is raining, and that particular man is standing. He is not moving with respect to the ground, and he has an umbrella too. He holds his umbrella at an angle of 30 degree with the vertical to protect from the rain, because he wants to protect himself. That is why. And after some time, he throws his umbrella and starts running. In a straight line on a horizontal road. In fact, road is horizontal and straight as well, with the speed 10 km per hour. Then rain, or you may call it raindrops, hitting his head vertically. Then we have to find the speed of the rain with respect to ground frame and as well with respect to the moving man. This is the projection of the problem, and now we are going to solve it. Look at, just we have to solve this problem. People are solving this problem or these types of problem in different fashion, but I am going to solve this problem here for you by equating the actual components of rain or raindrops in two different situations. X component in the situation 1 equated to the x component in the situation 2 in a similar manner. Y component are to be equated, and then we will find the solution of the problem. Look at how. Just look at here. Here is a man holding his umbrella. Standing, holding his umbrella, So this way is 30 degree, or that way like that, or 30 degree width, because it is not mentioned in which way he is holding his umbrella. Only 30 degree with the vertical. Then which way? But the way also depends in which fashion the man starts running. However, horizontally, so either right or left with respect to me. So here, suppose when I start to run from here in right way, the speed is already given, but suppose when the man was standing, so we take at situation 1. Now we have to take here x-axis and y-axis. Now the man starts running, say V man is equal to 10 km per hour. Then the rain or raindrops hitting his head vertically. So this is the velocity of rain with respect to man. Now we have to decide whether he was holding the umbrella either this way or that way. So we all know here the concept of relative velocity, velocity of rain with respect to man. This comes out to be velocity of rain plus minus of velocity of man. Nullifying the velocity of man, and it is added to the velocity of the rain, then it will provide us velocity of rain with respect to man. So minus, just we have discussed in the last class, so this is minus Vm, only multiplying with the minus 1, alter the direction but magnitude remains same. That's okay, fine. So here, so take, this is the direction of velocity of the rain, in fact actual velocity of the rain, because man was standing at t is equal to 0. After that it starts running, so that is why, so take like that here. Suppose in this way man was holding the umbrella. So now look at here, this is the velocity of rain, and look at here, velocity of rain with respect to man. Look at here, so velocity of rain with respect to man, the velocity of rain plus of velocity of man with minus sign. So this is the angle, look at here, and that is the angle as well, look at here. So as we know, a smaller of these two may be taken as angle between vector. So velocity of rain with respect to man somehow passing through here. But this is the velocity of rain with respect to man. So surely the man was not holding his umbrella this way, because the velocity of rain with respect to moving man is vertically down. But if we taking like that, so this comes out to be in this direction. So no way. So definitely let us try this one is or not. So this manipulation is ruled out. Now take this one. This is the velocity of rain. Now again look at here. Again two angle is here between minus velocity of man and actual velocity of rain. So this is here and that is the angle. Again, this angle is smaller. So a smaller angle is the angle between vector. Keep in mind. And resultant must pass through a smaller angle. That is the angle between the vectors. So yeah, this velocity of rain with respect to man corresponds that. Okay. The man must hold his umbrella when he was standing at 30 degree with the vertical in this way if he starts moving horizontally in right direction. Of course, if the man starts moving leftwards, then by the same manipulation you may find that the man must hold his umbrella by this way, making again 30 degree with the vertical. So it's all depends on that whether the man starts moving, starts running right way or left way. So I have provided you the explanation when the man was moving right way. That's clear cut. Crystal clear concept is required. That is why now we are in a comfortable zone to solve this problem. This corresponds the actual situation of the problem. Now we are in a comfortable zone to take it out. So this is the situation 1 and this is situation 2. So again taken as a x-axis and this is taken as a y-axis as usual. No cumbersome at all. So here look at here. This is the actual velocity of the rain because man was standing, was not moving. That is why. Okay. So we have to find x and y component. Just we are going to use here geometrical method as we have discussed earlier. Look at here. This way pointing in the positive. So we have the plus sign. Here rotate vectors in the same quadrant in which the vector lies. Keep in mind. So here pointing in the negative, put the minus sign before that and the plus sign for the x coordinate. So here situation 1. This is the situation 2. So here Vrx actual x component of the rain or raindrops is equal to mod Vr. So here mod Vr you may take as V. So mod Vr. So this is 30 vertically opposite, this is also 30. So this is cos and perpendicular to this is the sine. Here sine 30. So this is the V, sine 30 comes out to be half. This is equal to V by 2. Now again Vy. So this comes out to be minus because pointing in the negative y direction. Look at here. This is the negative y. This is the positive y. This is the negative y. This is the mod velocity of rain. Cos 30. This is minus V. Cos 30 is root 3 over 2. This comes out to be minus root 3 by 2 into V. Now in situation 2. Look at here. What we have to do in this situation? So velocity of rain. So firstly we write the vector relation here. Velocity of rain is equal to velocity of rain with respect to man plus velocity of man. So here Vrx, Vrmx plus Vmx. So look at here. So velocity of rain with respect to man in situation 2 is vertically down. So either this way 90 degree or by trigonometrical method 270. The cos of 270 or cos 90 gives you 0. So this comes out to be 0 here. Velocity of man. So moving in the positive direction. So here Vm cos 0 is 1. This comes out to be velocity of man, which is already given. We have to put the value of Vm to get the answer. Now similarly Vry Vrmy plus Vmy. What is Vrmy? So this is the situation 2. So this is this modulus say taken as V prime. So here this is V prime, but with the minus sign. Look at here. Why? Because pointing down. And velocity of man with respect to y, so it is moving along the x-axis. There will be no component either with cos 90 or with the cos 270. This is the 0. So this comes out to minus V prime. So actual velocity of the rain remains unchanged, either in situation 1 or in situation 2. So we have to equate. As I have told you earlier, we have to equate. Fantastic method. However, you may apply any other method. Various methods is available there, but this is the unique one. If you fill, then. So equate like that here. So in situation 1, Vrx is V over 2, and here in the situation 2, which is the Vm. So this implies here V is equal to twice Vm. So now it comes out to be twice 10 km per hour. This is 20 km per hour. Now Vy, look at here. So y is here minus V prime. This is equal to minus root 3 over 2 V. So minus minus cancel out here. V prime is equal to root 3 over 2. V is calculated here 20 km per hour. So after cancellation, look at here, comes out to be 10 root 3 km per hour. Now we are going to take problem number 3. Look at so we have a truck is moving in a straight horizontal road, straight horizontal road, and a person is standing on the truck. And this truck speeds in a straight horizontal road is given, say V truck with respect to ground frame, supposed to be stationary, given 14.7 meter per second. 14.7 meter per second. This person has a ball in his hand. He throws his ball in such a way that the ball again came to his hand or on the truck. After truck has moved 58.8 meter. After the truck has moved, say distance D is equal to 58.8 meter. Then we have to find the speed and direction of the ball, the speed and the direction of the ball with respect to an observer standing or sitting, not moving on the track. And the same problem, that is the speed and the angle of projection of the ball with respect to ground observer. Say one of the observer either sitting or standing on the ground, which is not moving with respect to the ground. So question is very clear now. Just I am going to repeat again. There is a truck moves in a straight horizontal road with a speed 14.7 meter per second. A person is standing on the truck, not moving on the truck, throws a ball in such a way that the ball again came to the hand of the person or may fall on the truck. During that period, the truck has moved or covered distance on the straight horizontal road 58.8 meter. 58.8 meter. Then we have to find the speed and angle of projection of the ball with respect to truck, in short, and the same with respect to the ground. That's the problem. Just we are going to solve it. So before indulging in that, we have to make certain assumption. What is the assumption? The height of the person is supposed to be negligibly small, and as well the length of truck is supposed to be negligibly small. These two we have to make assumption before indulging in that particular problem. One can ask you by writing this problem, and after certain assumption or after writing certain assumption, then you solve the problem. Then the problem becomes very, very interesting. However, we have to make the assumption. Under the assumption, just we are going to solve the problem. Now problem is very clear. Unless we are not able to solve this problem. Keep in mind. Now, let us start. So here firstly we have to work with respect to the truck, that is in truck's frame. So from truck frame, say with respect to truck frame, the ball is thrown with the speed say v with respect to what is called truck, making an angle theta with the horizontal. So we have to resolve it here. This will give you v cos theta and this will give you v sin theta. V cos theta, v sin theta. Okay. So what about the acceleration? So supposing here it is in uniform gravitational field, no problem at all. No problem at all here. So velocity of ball with respect to truck is the velocity of ball plus or minus velocity of truck with respect to ground. Now acceleration of the block with respect to truck, acceleration of the ball, not block, ball, plus minus acceleration of truck. So firstly we have to work on that. Here suppose this is the coordinate system, say x and y. So ABTX, ABX minus ATX. Once the ball has thrown, so it is under gravity. So with respect to ground frame, this acceleration component with respect to ground frame, so G, no machine or anything has been attached to the ball. So this G has no component because look at here 270 degree by trigonometrical method, mod G cos 270 comes out to be 0. So this is 0. And the truck is already moving with the constant speed in the horizontal direction. So this is 0, so it comes out to be 0. So with respect to truck frame, the x component of the acceleration of the ball comes out to be 0. Okay, and now this is the v is already assumed that here this is the velocity of ball with respect to truck, and this is the velocity of ball with respect to truck x component. So this is constant and there is no acceleration, so we may apply dvt. We may apply dvt. So now we have to apply dvt here. Distance is equal to speed into time. So distance is equal to speed into time. What is the speed here? Look at v cos theta, and time is say t. That's the problem here. I have written deliberately. Why? Because these types of relation dvt works well in class 9 and 10. However, it may works in higher classes too. Just we have been used in this class earlier, in the earlier problem, but here there is a problem. That is why we have to write x motion. However, we haven't tried here how one can write x motion and y motion. So just we have to borrow this relation from kinematics, and we will show later on in very detail. So just we are going to not use this relation. I have written this relation deliberately to show how one can do mistake. That is why. So we have to write x motion here. So x is equal to x naught plus v naught x into t plus half ax t square. This is the general relation. We will derive in the subsequent lecture, but right now we borrowed it from there. So in track frame supposed to be here origin, here the x axis, y axis. So the ball is thrown from the origin, so x naught is already 0. v naught x with respect to track frame, here is the v cos theta. It takes time t, half ax. Look at here, acceleration of ball with respect to track x component comes out to be here 0. Here 0 into t square. So finally we have left with v cos theta into t. This is x. This is not a distance, and earlier D was the distance what I have written deliberately to show the significance of x motion, y motion, z motion. So here x is the coordinate. What problem says? The ball after certain time came to the hand or falls on the track, supposed to be negligible length, then at the origin. However, if looking from the ground frame, origin is moving, but with respect to track frame, origin is static. So the x coordinate is 0. That's the beauty of x equation. So here this implies v into cos theta into t is equal to 0. Look at right hand side 0 or right side 0. Left side has three factors, v, cos theta and t. So v, speed, yes, there is some speed, after which the ball moves in air or in uniform gravitational field. So surely we have to provide certain v. So v is not equal to 0. What about time? So it takes some time. Already problem says it takes some time. However, our common sense also, our conscience also allowed that yes, it takes some time t. So the two factor is not equal to 0. And the right hand side is still 0. Definitely cos theta must be 0. Otherwise, how one can say that this relation is valid? Because v is not equal to 0, t is not equal to 0, and right hand side is 0. So it is possible only when cos theta is equal to 0. Otherwise, no way at all. So this implies, because here we see that we have to provide some speed, so v is not equal to 0. It takes some time, so t is not equal to 0, but right hand side is 0. So only possible when cos theta is equal to 0. This implies cos theta is equal to 0. This implies theta is equal to odd multiple of pi by 2. Odd multiple of pi by 2, where n belongs to integer. So here acceptable solution in this particular physical situation when n is equal to 0. So theta is equal to pi by 2, or you may say equivalently in degree measure 90 degree. So look at here, this came from mathematics. One may say that mathematics is ocean and physics is a glass of water here, because there is a lot of solution exist here for which cos theta is equal to 0. But look at here, only one of the solution in this particular physical situation is acceptable. So with respect to truck, or with respect to an observer which is sitting or standing on the truck, finds that the person throws the ball straight up 90 degree, because we have taken angle from horizontal, so straight up. So from truck frame, direction is already measured. Now we have to measure the speed, because we have to measure the velocity. Velocity is a vector physical quantity. We have to measure both direction as well as magnitude. So direction is already done, vertically up. Now we have to measure the speed, that is the magnitude of the velocity. Look at how. So here now here a, b, t, y. So here a, b, y minus a, t, y. So a, b, y is minus g. A, t, y, because truck is moving with the constant velocity in the horizontal direction, right way, look at there. So it comes out to be 0. This is the minus g. So goes up say somewhere here and comes back. Why we saying like that? Because of the fact that, as problem said, the ball came to the hand of the person, or the ball lands on the truck after some time. That is why. So here, time of flight. So we have to use what? Y motion. We have to use y motion. So look at here. Y is equal to y naught v naught y into t plus half ay t square. So it is thrown from the origin, so y naught is 0. Again came to the origin, so again this y is also 0. Beautiful. Now here v0 y, so straight up with the speed say v, because we have taken v. So this theta become 90, then sin 90 is 1, so only v is here. So upward, that v is positive, into t, we have to find t, plus half ay is minus g, look at there, into t square. So this implies, take t as a common, so here v minus gt over 2, and this is equal to 0, so it takes some time, so this factor cannot be 0. So right hand side is 0, so it is possible only when this factor is 0. So this implies that, look at here, t is equal to twice v over g. Now take it as a 1. Now look at, we have to find v. Still there is one unknown remains in this relation, because g is known already, 9.8 or 10 meter per second square, that no matter at all, it is already given in the problem. And t here, we have to find t. Look at what problem said. When the ball again came to the hand or falls on the truck has been moved with respect to ground frame 58.8 meters, look at there, with constant speed. Now here there is no harm to use dvt. So here there is a harm to use dvt. So that is why we have been used x motion and here is the y motion. But here still we may use x motion or y motion like that, z motion maybe. But because here we use class 9-10 concept dvt, no problem at all. So for truck with respect to ground frame, take the help of ground frame to find t. That is why use dvt. So d is equal to v into t. So here t is equal to d over v. So d is 58.8 meter and v is 14.7 meter per second. So meter is cancelled already. Here for second. This is the total time of journey. Now in that total time of journey, so this is the 2v over g. So take it as equation number 2. So now from equation 1 and 2. From equation 1 and 2. So v is equal to g into t over v. What is g? Take it as 9.8 t for by 2, sorry, by 2 here, 2. Take it 2 to the 4, 9.8 to the 19.6 meter per second. So with respect to truck frame, we did our task. Direction perpendicular and the speed 19.6 meter per second. Now we have to work from ground frame. So from ground frame, from ground frame. Velocity of ball from ground frame, velocity of ball with respect to truck frame or with respect to truck plus velocity of truck with respect to ground. But ground is generally we do not write. If we write, then no problem. So understood, v truck means plus your truck with respect to ground. Okay. Now here vbx, so it comes out to be vbtx plus vtx. What is vbtx? Because it is thrown up, so there is no vbtx. This comes out to be 0. Vtx already known here, 14.7. 14.7 meter per second. Now what is vbty? Look at here. Sorry, vby, vbty plus vty, truck, y component. Velocity of ball with respect to truck, y component. So it is going up. So this is v and this is going horizontal. So mod of that cos 90 comes out to be 0. So here 0 comes out to be v. So v is already, we have found right now 19.6 meter per second. So now we are able to find this comes out to be vbx whole square plus vby whole square, so square root of 14.7 meter per second whole square plus 19.6 meter per second whole square. So after finding, it comes out to be 24 point, subdecimal say 24 point, we have to find it out, 14.7 whole square plus 19.6 whole square. So 24 point, what it comes out to be, decimal point, meter per second. So no problem at all. So this is 20, then 400, and this is if 15, then 225. So altogether 625. If like so, then answer would have been 25 meter per second. So it is not so little bit less than or little bit 20 less than, so 24 some decimal point. You do the proper calculation, find the decimal point, it is up to you. But right now the angle, so say velocity of ball with respect to ground frame, say makes an angle alpha with the horizontal, then tan alpha is equal to vby over vbx, and this comes out to be, so vb by here 19.6 meter per second over 14.7 meter per second. So meter per second is cancelled out here. So this is 196 over 147. So this implies alpha is equal to tan inverse of 196 over 147. So you may live that way of if you calculate. So this approximately comes out to be, I think so, 53 degree or so. You may find it quite comfortably, no problem at all. If we leave this answer in this fashion, then okay, no problem. So in this way, we did the problem, we solved the problem, either from truck frame or from ground frame. That's okay.